This is Boeing's X32, and together with my friends from RC Jet Print and thanks to Autolevel, we made a printable version out of it, and it flies really awesome. Check out the landings. After some successful flights, we know the CG, we know how it flies, we know how it reacts. Now it's time to make the ultimate model. That is to make it a VTOL. So vertical takeoff, going to transition and fly it around, and perhaps also do a vertical landing if we have enough battery life. So in this video we're going to make a second model. We put this model aside and we have already printed a new model thanks to the spools from Autolevel. And also, we're going to show you how the KK2 board works. Yes, we're going to do a walk around the airplane, show you which parts I use. And on Instagram, you all, like 50% of you, guess which engine I'm going to use. These are from JP. These are quite powerful, and also the gap between the blade and the rotor is really narrow. So these are quite efficient motors. So, I would say, let's start. Okay, I already prepared with some friends the next fuselage. As you can see, the JP is already inside. To go in vertical mode, the EDF will tilt down, and in forward mode it will go horizontal to give a push of 6 kilos out of it. It will be an 8S setup to give also the pitch stabilization, which I'm going to explain later in this video. We use 40 millimeters in front, 2 times, and also 2 in the wing. So let's start preparing the parts and let's start assembly. Okay, here we got our rudder. Which also fits nicely. And then we put a 5 millimeter tube all the way through, and then it's stuck, so you don't need to glue the rudders. And easily remove when you got some damage. The same for the right rudder. There we go. Okay, let's start cutting the centering pins. Okay, let's slide it in. Here we go. Okay, the wings are installed. Let's proceed with those rudders. Okay, it started looking like an airplane. Let's continue with the ailerons, flaps, and adding the cockpit. So we use a simple hinge system, which is already printed in part. And we just click them on the spot. And then you put a tube inside. Here you go. The X32B has 2 typical small long front leading edges, so we will add them also in our model. Let me see, this one is left. It's the opposite side, sorry. Yes. And this spot is actually for the servo to move this front leading edge. We will use this during landings, takeoffs, and during transition mode. Therefore, we're going to use a small high-tech HS-30s to control it. Okay, let's continue. And save this part for last, the cockpit. So the cockpit, we will install it later on with magnets. But now I'm going to tell you about the KK2 board, how to recognize the setup. Let's go. Okay guys, this is a KK2 board. We use them also in the F-35. And we're going to use the same board for the X32. So actually this is a quite easy mixing board. You got 8 outputs, you got your inputs, but you can also use a UDI signal. But let's take a look first what we recognize on this airplane and how that we're going to make it hover. I'm sorry for not having fancy animation software, but I hope you will recognize it. So this is basically the setup. So what do we have? We got our CG, which is where the main EDF is located. It's a little bit the same as the Harrier, but we don't look at the center motor. So let's see what we have. We got motors on the wingtips, and I told you in the beginning of this video, we got also motors in the front of the nose. So basically we got a tricopter setup. So this is what we're going to implement. So let's write it down. Okay, we got our 2 motors in the wings. We got our motors in the front, and we call this let's say out 1. This compares also to output 1 on the KK2 board. So what do we have? We've got a tricopter setup. What it needs to do, it must provide lift and it must provide pitch, right? So what we give to output 1, we give it a throttle, and it needs pitch, so elevator, right? Okay, let's continue with the side EDFs. So we got 2 different side AVS. It got multiple functions. For jaw control, we are going to tilt this EDF. So we have a servo input. It also needs to do some pitching, but more important also is it needs to roll. It needs to be stable. So let's write this one down. We call this output 2 and this output 3. So let's go to this, where we say output 2, 3, and you got 4 for jaw. Okay, let's write down output 2. So out 2, it needs throttle, it needs elevator, and it needs aileron. Agree? So let's continue to output 3. It needs also throttle. It needs elevator control, and it needs a same roll, aileron. So far so good. And for making it the Z axle, to move jaw, output 4, which are basically servos, we only use jaw. Keep in mind, guys, that this board is already flashed to OpenAreoVtol. There's a nice thread on RC groups who explains you everything about the board and about to flash it. But this I will tell you in another video. But for now, let's see how we're going to implement these outputs into the KK2 board. So before we move on with the KK2 board, I hope you all understand what I'm trying to explain on the board. So to provide pitch angle, the front motors needs to lower down in RPM, and the back motors must gain in RPM. So we call this thrust differential in pitch. The same if we look for the roll authorization. If you want to roll to the left side, this motor must reduce in RPM and this motor must increase in RPM. So you got your thrust differential between those 2 EDFs. For moving or drawing the nose this direction or that direction, and in helicopter mode we call it also heading lock mode. We will also implement this. So if I want to turn to the left, this motor must blow forward and this motor must blow backwards, so it will turn on its z-axle, and the other way around. So if we want to go to the right side, this must go backwards and this must go forwards. So you got your left turn. And during transition mode, yeah, they can probably also mix both to the front, that they help with speeding up the airplane. But this is already next level, so let's keep it simple for this setup because we want to hover it soon. Okay, let's go back to the KK2 board. Okay everybody, we got a flashed KK2 board. Let's fire it up. It's got already OpenAreoVtol installed, and I will try my best to explain how it works. So we don't going to take a look to all the settings this video. Let's implement the settings that we found on our board. So we figure out what kind of setup do we need, this tricopter setup, and now let's implement it. And let's say that P1 is forward flight mode, P1N, this is the outbound or inbound mode, and P2, this is hover mode. But this will be for the next video. So let's go through the KK2 board. I hope you can all see it really clearly on the screen. And let's find output 1. Output 1 mixer. Let's go for it. So the device is indeed a motor. During forward flight in P1 mode, I don't want any throttle, so the motor must be switched off. And during hover mode, we're going to give this motor a volume of 80%. I don't know if it's exact 80%, but let's say 80 to start with, because you need, for roll authorization and pitch authorization, you have throttle differential. So if you put it already on max throttle during hover and you want to roll or pitch, you need some extra RPMs to provide this. That's why I put it on 80. We also decided to give it a pitch authority. So we're going to P2 again, and we're going to give it like, let's say 30, 35. It's my favorite number, F-35. I don't know. We are just playing with the settings for now, but we're going to implement the basic settings. What we also do need is we want also pitch gyro, which is already on, and I do like Autolevel, and I put it on scaled. Maybe it's just on. You can choose between on or scaled, but somehow I like this Autolevel. So far, so good. So we're going to the output 2 mixer, which needs ailerons. As you can see, there are already some settings, so I don't want to have throttle during forward flight, so we put this one on 0. For output 2, throttle we're going to put on 80%. Transition curve is linear. You want roll. So now you see actually a positive number, but if it's moving the wrong side or reacting the wrong side of the gyro, we basically put it minus. This is how you can reverse the input if it is reacting the wrong way. So we don't take a look at the controls on your transmitter. No, we just now take care about the settings. So this we put on 35. Same as for the pitch, because the center of gravity is quite in the middle. And we also want elevator volume. We don't need rudder volume. I want to have some roll gyro. I need some pitch gyro. Autolevel, of course. And I want pitch autolevel. So far so good. We're going to output 3 mixer. So this is actually this pin. So we have a motor. Put it on 80% throttle. And the transition curve is linear. P2 because the other one was plus and the other needs to counter react this motion, so we put it on minus 35. And elevator we give also minus 35, because no, this is the back, so this is plus 35. Okay. If you need some extra questions or explanation, just let me know in the comments. We don't need rudder volume. Roll gyro could be on. Pitch gyro on. So if you find it, your roll authority from the KK2 board is too weak and you need more stiffness, you can adjust this to scaled. So normally it's on, but if you want to have more control or more stability, you can put it on scaled. So this will double the inputs from your gyro. Roll auto level scaled, of course. Pitch auto level scaled. So these are the three setups, because the front two motors I will put simply an Y cable. And now we go to output 4, which is jaw. So this is a digital servo. We don't need throttle volume. So we put this on 0. It's in servo, so it doesn't need any throttle. We don't want aileron volume. We don't want elevator. Here we go. We need like 100% rudder volume. As simple as that. Can you still follow me? And of course, we don't need roll gyro, we don't need pitch gyro, we only want to have jaw gyro. And I will put this directly on scaled, and I will show you later on why I put this on scaled. So we save it. We check the other settings. This must be 0. So guys, this is for me the first time I try to explain the KK2 board. If you have some ideas or suggestions, just let me know in the comments and I will implement them in the next videos. We don't care about the output offsets. This is basically some kind of a trim. The curves is not important for now. But we're going to take a look at number 1, general settings, how it's put it. And again, there's a really nice manual on RC groups. Receiver, I use ODI, so it's only one cable needed. And somebody from Switzerland told me that I need to put the outbound transition as long as possible. So I will listen to this guy. Inbound transition. So again, you got P1 for forward flight. You got P1N. This is called outbound and inbound transition. And when you have a full transition into forward flight or hover, yes, that is the third mode. So this is the midpoint. How many seconds it takes inbound? It can be quite fast, by the way. So here we go. Receiver inputs, we don't know yet because we didn't attach the receiver yet. We have also a nice level meter, which is a really cool feature on this KK2 board. So it wants, during Autolevel, it wants to keep inside of this square box. But when you tilt the board, you see, you can play a little bit of game out of it. But I always want to try to keep it in the middle. You got your PI settings, PID. So it depends on which kind of aircraft that you are playing with. But okay. So this is a lot of information. The basic point is that we put in the mixers for the front, back, and a roll, and settings for the servos for jaw. So let's try to implement these. So let me grab a receiver, bind it with my JT, and let's connect some wires to see what happens. Okay, let's go. Okay guys, I touched the receiver. Let's boot it again. Okay, so let me check the inputs. So as you can currently see, it's in P1. We call this flight mode. We will switch it to P1N, which is our outbound or inbound mode, and we can switch it to P2, which is our hover mode. Okay, so let's keep it on flight mode for now. There you go. So let's see my inputs. I think they're already quite nice, well tuned. So like I said, I use a single cable for my duplex receiver. And let's see if my inputs are good. Okay, here we go. My gear switch is what I've used for my flight modes. You got my throttle signal. Cool. We got my aileron, elevator, rudder, and like we discussed, gears. I don't use the auxiliary outputs because yeah, we don't have any doors yet. So what we can also do is for the guys who are questioning, I have used now like 4 outputs of the KK2 board, but there are still 4 left, and I can use this to control the ailerons, the flaps, or the rudders. And this is quite easy if you don't have that many channels on your receiver. So I'm using a 6-channel receiver, and we will find out if this is enough. So let's put in the KK2 board in the X32. Okay, let's grab our battery. Let's switch this on. So it's binded. Let's try that. Okay. So we're now in P1. And as you can see, the motors are not responding because this is flight mode. So we switch it to flight mode, hover mode, I mean. So we got throttle. And now we're going to check if they are responding. So when the nose is tilting downwards, I want to have more throttle. So this is wrong. So what we do, we need to reverse the volume for pitch. Understand? We don't take a look at the transmitter. We're going only to look at the pitch. So let me grab the camera to show you. So what we're basically going to do is we're going to go to the settings menu. We go to output 1. Here we go. Let me put this cable aside. Then we're going to find the elevator mix. This cable is still not focusing my lens, so this is better. Here we go, we put it on -35 because it needs to respond the other way around. We save it and go back to this point. So let us give us another try. So we give it a little bit throttle. We lift the motor. Perfect. Nose up. This works. Okay. So the front motor seems to respond. Now we're going to give it a pull. Perfect. Nose down, forward, off. Nose up. Nice. So my inputs are correct. Wow, 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 wow. These 40s are really powerful. So our input is correct. And when I switch it to flight mode, nice, huh? And now we're going to outbound or inbound. And we got the ready control. And we're going to hover mode. Yes. Nice. Okay, let's proceed with those back EDFs, and therefore I need to weld a new cable. Let's continue. Always disconnect the LiPo if you're going to do something else. Let's continue with the jar servos. I will make this cleaner afterwards, but let's see how it behaves. When I turn the model to the... Okay. You already see that it's moving, correcting the wrong way. See? You can see it also better. So this must be the other way around. So if, like I told you before, with pitch, we're just going to make the input negative. So let's go to the menu again. Hope you can see it. We go to output 4. And again, we don't look at what's happening on the transmitter. We need to check first if it's responding the correct way. So we got an input of 100. Let's change it to minus 100 and see what is going to happen. So this is just a starting point. If we see if the model is going to shake or oscillate, then we can lower down this number. But for now, this is a nice starting point. So now we're going to check. This is better. Nice. So this is responding the correct way. And this one, yeah, it's on AKY cable. Perfect. Now we can also check my rudder input. So this is also, so when I go, yes, to the left, it blows backwards. When I go to right, it goes blowing backwards, and the other way, opposite around. Nice. So we got also the transmission of the transition switch. So when I turn this on, 5 seconds, and now it's standing completely still. So during flight mode, these are switched off. I can turn it back on to hover mode, and you see it start responding. So draw is correct. Let's move on with pitch. So let's connect the back motors. So the front motors, I will keep them shut off. Okay, they are calibrated. Okay, let's do something. Let's see what is going on. Okay, this is acting the wrong way. Pitch. Pitch is perfect. So pitch is fine, but roll is the opposite around. So we need to change them both. So now you see that my rolls are reversed. So what I need to change is to make this number negative and this number positive. So I will put this one minus and this one plus. So out 2 plus 30, minus 35, and out 3 plus 35. Let's go. So again, we're going to jump into the KK2 board. We're going to search for the output 2 settings. Output 2, yes. And now we need to reverse the aileron input. Here we go. So now it says plus 35. and we're going to change this to -35. Okay, and we will do the same for output 3. Go to aileron and make this plus. And again, we don't look at the inputs from the transmitter. We just see how it behaves. Okay, let's go. Yes, let's try it now. Okay, let's give it a little bit throttle. So when I tilt this one, it must go off. And that one is compensating. The other way around. Nice. Oh, that one. And we got the same for pitch. When I tilt it forward, it must go off. And when I tilt it backwards, it needs to respond. Nice. And also your jaw. Nice. So everything seems to respond fine. So the next step is to connect all motors. And let's see what happens. Nice, 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 nice. So all reactions are correct. Let's see if the transmitter, so throttle, we go to the right, that one go. Okay, this is fine. Nice. So we have our basic setup. Okay. It's all working really fine. Okay, everybody. So I hope you learned something today. So I told you something about the KK2 board. When it's flashed to OpenAreoVtol, you got all those free mixers, and you can switch between P1, which is for fast forward flight. You can switch to P1N, which is for outbound and inbound transition. And you can switch to P2, which is hover. I also showed you how to start. So we started to make a recognition, how to recognize your setup. So we choose for a tricopter. The second step is what do we need? So for the out 1, out 2 and out 3, I explained you how to recognize and how to fill this into the KK2 board. Then we went to test to see if the KK2 is giving the correct output corrections. So you saw also negative and positive numbers. So to reverse, you just simply make a number positive or negative. We also checked on the drum momentum, which is working also really nice. It's responding really awesomely, by the way. So yeah, I hope that you really learned something, and always write down the numbers what you've done, and you can also use that for a second model, or yeah, just to know where you are standing at. In the next video, I'm going to tell you something about P, I and D values. So you can tune the P and the I in the KK2 board. And yeah, we're going to work to get our first transition and mostly hover in the first time. Yeah, so you need to learn to see the behavior. So when you got oscillations or it's really sluggish, you need to get control and stable control during hover. Yeah, that will be shown in the next video. Now, I hope you really learned something. Thank you all for watching my video. Thank you all for sponsoring me. The sponsors like ColorFab, Bamboo Lab, Longer, and all those other nice printing brands. Without you, it's really difficult. And also my friends from RC Jet brand. Thank you so much, guys. I really enjoy our challenge together and journey together. So guys, I will see you in the next video where we're going to try to make our first hover with this model. Flying you've already seen, but hover, oh, this is going to be awesome. Okay guys, see you in the next one.